Okay, so now our more usual derivative taking using our derivative rules. All right, so let's find a derivative in each case here. So when I look at this first one, I must notice, yes, this is a product of two functions of x. Okay, so when I want to do dy dx, or I could do y prime, it's the derivative of the first, 3, times the second as it is, e to the x squared minus 1, plus the first as it is, 3x times the derivative of the second. But that's e to something. So e to the x squared minus 1 times the derivative of that something up there, which is 2x. So I get 3e to the x squared minus 1 plus 6x squared e to the x squared minus 1. If I wanted that a little factored, looks like I take out a 3 e to the x squared minus 1 times 1 plus 6x squared. And there we go. Whoops, sorry, back up. I forgot to take out the 3 from the 6, and that should be 2x squared. Okay. Y equals 3x minus 1 over x squared plus 3 squared. Okay, so the first thing is, this is something squared. Okay, so the first thing when I go and do the derivative, it's that 2 times this something, now to the 1, or I don't have to put that, times the derivative of what was inside. Now to do that, I do a quotient rule. So the derivative at the top is 3, times the bottom as it is, x squared plus 3, minus top as it is, 3x minus 1, times the derivative of the bottom, which is 2x, all over x squared plus 3. All right, so I got to do a little work here. So I still have that 2 on the outside. I have a 3x minus 1. Notice I now have x squared plus 3 squared down there. And then I have to resolve what this numerator is. So that's 3x squared plus 9 minus 6x squared plus 2x. Okay. Giving me, 2 times 3x minus 1 times, so that's going to be minus 3x squared plus 2x plus 9 over x squared plus 3 all squared. And that quadratic in the numerator is not going to factor, so we will leave it like that. Okay, C now. 3 sine 2x plus 1. Okay, so when I go to do the derivative here, 3 in multiplicative constant stays there. So now I have sine of something. So on derivative, that would give me cosine of 2x plus 1. And then I have to go inside and take the derivative of 2x plus 1, giving me a factor of 2. Meaning in the end, I get 6 cosine 2x plus 1. All right. Y equals x ln of inverse tan x. Okay, so what do I notice first? Okay, well, this jumps out at me. I don't want to see that first. I want to see actually I have a product. Okay, so when I do the product rule, derivative of the first is 1, second as it is, ln inverse tan of x, plus first as it is, x. Now I want to do the derivative ln of inverse tan of x. Okay, that's a chain. Ln of inverse tan of x. So that's 1 over inverse tan of x times the derivative of inverse tan x, which is 1 over 1 plus x squared. Okay, so doesn't look like there's a lot I can do here. Ln inverse tan of x plus x over 1 plus x squared times inverse tan of x. That's as good as that's going to be. Okay, so in this one, I see sine of xy minus x plus y equals 1. And I notice that because the y is embedded in the equation here, I'm going to need to use implicit differentiation. So that means I'm going to take the derivative of both sides here with respect to x. And when I go on the left here and I see the derivative of sine xy, that's sine of something. So I get cosine xy. And then I have to go and take the derivative of the xy, but realize that that's a product of two functions of x because y is a function of x. So I have to do product rule. So derivative of x is 1 times y as it is, plus x as it is, derivative of y is dy dx. That takes care of the derivative of sine xy. Then the derivative of minus x is minus 1. And the derivative of plus y is plus dy dx equals 0. Now I need to solve for dy dx. So I multiply out y cosine xy plus x cosine xy times dy dx minus 1 plus dy dx equals 0. So leaving the dy dx terms on the left and factoring it out, so dy dx equals, dy dx times, I would get an x cosine xy plus 1 when it comes out of here. On the right, I would get the negative 1 moving over and the y cosine xy moving over, so I'd get 1 minus y cosine xy, and so ultimately dy dx, I get 1 minus y cosine xy over x cosine xy plus 1. Sorry, that should be a cosine xy down here. Let me get that right. Cosine xy plus 1. Okay, so now I have a very complicated expression in y, and so I'm going to use logarithmic differentiation here because it's going to make it a lot easier. So I apply ln to both sides. So here I get 3x plus 1 times, I'll write it as x plus 2 to the 1/2 over x minus 1 squared, 5x minus 2. Okay, and the benefit here is that I can write this right-hand side a little differently. So what I'm going to do is it's ln of the numerator minus ln of the denominator. That's just from my logarithmic simplification rules. But that gives me logs of powers. So that's ln of product, sorry, of ln 3x plus 1 plus ln x plus 2 to the 1/2 minus ln x minus 1 squared. And it would be a plus, but there's the minus outside that makes this a minus ln 5x minus 2. Finally, I can also use the powers to come down. So plus 1/2 ln x plus 2 minus 2 ln x minus 1 and minus ln 5x minus 2. Now I can go and do my derivatives, now implicitly really. So I do the derivative of ln y, I get 1 over y dy dx. And now when I take the derivative of ln 3x plus 1, I get 1 over 3x plus 1 times 3, chain rule, plus 1/2 times 1 over x plus 2 times 1, minus 2, 1 over x minus 1, minus 1 over 5x minus 2 times 5. So to clean this up, I'm going to do two things. I'm going to, make those fractions a little nicer inside, but then I also have to bring that y over and replace it with what it originally is. So that's a 3x plus 1 times the square root of 5x plus 2. 5x. Sorry, no, in the numerator, square root of x plus 2. Let me fix that. Bear with me. X plus 2 over x minus 1 squared, and then 5x minus 2. And then the 3 over 3x plus 1 plus the 1 over 2 times x plus 2 minus 2 over x minus 1 minus 5 over 5x minus 2. And there we go.